My name is Justin Roy, register number U15CS167, and this is my data structure lab experiment number 10. So the question is the implementation of linear sort. So let's see the program. So I'll start it by including iostream header file, then using names as study for the standard library function, and then I'm declaring an array of size 50 and a maxi variable, both of data type int. Then I'm writing this linear sort function. Then the main. First I'll explain the main. So I'm asking the user to enter the size, and the input is taken and stored inside maxi. Then I'm asking the user to enter the array, and I'm running a for loop from 0 to maxi and taking that input and storing that into a of I. And then I'm printing the array before sorting, and then I'm calling the linear sort function, and I'm printing the value of the array after sorting. So let's see the linear sort. So it takes two arguments. One is array and one is the size, and inside this function I have a temporary variable, and then I'm having a nested loop. And first the for loop starts from I0 to n, then the second for loop runs from I plus 1 to n, and then inside this loop I am checking if a of j is less than a of I. If it is like that, I have to swap those two values, a of j and a of I. So let's say the I is 0, and the j will become 1 that at that for the first time. So a of j will be compared with a of I, and if a of j is less than a of I, these two will be swapped. So after every iteration, the first element will be sorted. So when I is 0 and this loop, the inner loop terminates or completes its functioning, so the first element is considered to be sorted, or it is sorted. So when I becomes 1 and this loop terminates, the second element will be sorted, and when I becomes 3 and this loop terminates, the third element will be sorted. So like that, by the end of this loop, all the element will be sorted. So that's how the linear sort works. So let's compile it and see if it is working or not. So let's say the size is 5, and I'm entering the input. So array before sorting and after sorting, so it's showing correctly. So the second question is the implementation of insertion sort. So this is the insertion sort function, and this is the main. So first I'll explain the main again. Asking the user to enter the size and taking input in the array which I have already declared, and then I'm calling insertion sort function, then printing the array after sorting. So let's see the insertion sort function. Again, it takes array as argument and the size, and then I'm having two loops. The first is the for loop which runs from 0 to n, and the a of ith element will be taken as the t, and j index will be having the one lesser value than the I. So that means I minus 1 will be stored as the j. So j is also an index position. So then I'm starting a while loop. So it checks if a of j is greater than t, and j of j is greater than equal to 0. So let's say when I is 0, the j value is minus 1. So this condition will never be satisfied. So this loop doesn't run for the first time. So the first iteration, when I is 0, this loop doesn't run. So when I is 1, this j value will become 0, and this condition will be satisfied. And according to this condition, will this loop run or not depends upon this condition. So in the insertion sort, the first element is considered to be already sorted, and then the second and first element will be compared. And if the second element is greater than the first element, they both will be swapped. And after that, the third element will be compared with the second element, and if third element is greater than the second element, they will be swapped. And the second element, which is now the element which was in third position, so because third was greater than the second element was greater than third element, so the third element which was lesser is now in second position, and the second position and the first element will be compared, second position element and the first position element will be compared, and if the first element is greater than the second element, they will again be swapped. So like the swapping and the comparison goes on. So let's say at the fourth element is greater than the third element, so that means the after causing the because this is in the fourth iteration, that means the first three elements are already sorted and the fourth element is greater than the third element. That means there is no need to swap the third, that there is no need to compare the third and second element or second and first element, because they are already in sorted order, so there is no need to compare or swap them. And if the fourth element is greater than the third element, so that means we can simply go to the next loop. So let's compile it and see. So let's say the array size is 5. Now I'm inputting. So array after sorting is 1723, 56, 88. So it's showing correctly. So the advantage of the insertion sort is the the timing or the big of insertion sort is lesser than the linear sort, and the number of writing or the swapping is lesser in insertion sort as compared to the linear sort. Uh, so that's the advantage of linear sort over this linear sort. So insertion sort is better than linear sort comparing to the time complexity. If we are taking the time complexity into account, the insertion sort has the better time.